let's talk about angles, okay? And in order to talk about angles, we need to go back to geometry and remember some of the basics. So here we have a line. Remember that a line keeps going in both directions forever. And so we can name this line, line AB. Here we have a line segment. Remember that a line segment has two endpoints. And then we have a ray where we have an endpoint and a line that extends in one direction forever. Okay? So in order to have an angle, we need two rays. And where the rays come together, we call that the vertex. The initial side is the side that doesn't move. And then the terminal side, this side right here, is the one that's moving. Because remember, an angle is made by movement, okay? By the movement of the ray, okay? So a positive angle is where the terminal side rotates counterclockwise. So this terminal side is going to rotate counterclockwise in order to give us a positive angle. A negative angle would rotate clockwise, okay? And remember, an angle is the amount of rotation. Remember that an acute angle is in between 0 degrees and 90 degrees, not including 90 degrees, okay? And not including 0. All right, a right angle is exactly 90 degrees. An obtuse angle is between 90 and 180, not including either one of those. And then a straight angle is exactly 180 degrees. All right, remember that complementary angles are two positive angles whose sum is 90 degrees. Supplementary is two positive angles whose sum is 180 degrees. All right, so let's take a look at example number 1. Okay, find the measure of each angle in the figures below. All right, so let's pull out some of our geometry skills. Now we have a right angle here, so that means they're complementary. So these two angles have to add up to 90 degrees. And now we're just going to use our algebra skills. So M is going to be 6. And now it said find the measure of each angle, so we need to go plug that back in. So 8 times 6 gives us 48 degrees. That's a degree symbol, not a 0. And then 7 times 6, that's a 7. It's an ugly 7, but that's okay, is 42 degrees. Check yourself. Does 48 plus 42 equal 90? Yes, it does. So these are your answers. Now let's take a look at the second one. Here we have two adjacent angles that happen to be a linear pair because they create a straight line. And remember that a linear pair of angles is supplementary, so these two have to add up to 180. So 11k plus 7 plus 6k plus 3 equals 180. So we have 11k plus 6k, which is 17k. 7 plus 3 is 10, equals 180. And then subtract the 10. And then divide both sides by 17 and you get k is 10. But remember, they asked for the angle measure, so you plug it back in. So 11 times 10 plus 7, and that gives you 110 plus 7, which is 117 degrees. And then 6 times 10 plus 3, so 60 plus 3, which is 63. And those together add up to 180, so we know we're right. All right, so let's take a look at angles on the coordinate plane. All right, so here we have, here's your initial side, that's the x-axis, on the right-hand side of the y-axis. And our terminal side is what's making that angle, finding that angle of rotation. So this angle is A, and it's 35 degrees. So the measure of angle A is 35 degrees. And remember that portions of a degree are measured in minutes and seconds. You may not have known that, but if you've used GPS, you'll notice if you look at a location, they use degrees, minutes, and seconds to get an exact location. Okay, so 1 minute is a 60th of a degree. So a degree breaks down into 60 minutes. Okay, so 1 minute, that's the symbol for minute, is 1/60th of a degree, or 60 minutes is equal to 1 degree. And then 1 second we know is a 60th of a minute. There are 60 seconds in 1 minute. Okay? So for seconds, we use the quotation marks as opposed to the apostrophe. And so 1 second is 1/60th of a minute. So here you have 1 second equals 1/60th of a minute, which is the same thing as saying 1/3600th of a degree. And then 60 seconds is equal to 1 minute. Okay? So you're going to need to know that in order to perform some calculations. And again, this is used in GPS, so it's a very common way of describing an angle. All right, so we are going to add these two angles, and it makes more sense to me to line it up horizontally or vertically. So let's just line that up. So we get 32 degrees, 11 minutes, and 36 seconds. And we're just going to add it the way it is. Okay? So 14 plus 36 gives you 50. Okay? So that's less than 60, so we don't need to add it over to the minutes. 39 plus 11 gives us 50 also, so that's minutes. And then 48 plus 32 gives us 80 degrees. So our answer is 80 degrees, 50 minutes, and 50 seconds. Okay? If this had been, say, 60, then we could say, okay, well, 60 seconds is equal to 1 minute, so we could add 1 minute over here and just take away this and not have any seconds. Or if this had been 61, then you can take 60 of those seconds and make it 1 minute, so this would be 51, and then you'd still have that 1 second left. All right, let's take a look at part B. 90 degrees minus 14 degrees, 11 minutes, and 32 seconds. Well, we need to break this apart. We need to, all right, we'll just do it this way. All right, so we want to subtract from right to left, but we don't have anything here to subtract from. So we need to change that 90 into something that we can work with, okay? So let's do this. Let's take this away, and we know that we can convert 90 degrees into 89 minutes. 89 degrees, there we go again. So 89 degrees and 60 minutes. Yeah. Because remember, 1 whole degree is equal to 60 minutes. So now this is the same thing as 90 degrees. Well, we can also rewrite that as 89 degrees. We can take a minute out of this and convert that into 60 seconds. So now it's 59 minutes and 60 seconds. Okay? So this is all equal to 90 degrees. All of these things are the same value. All right, so then we just line up the 14 degrees, 11 minutes, and 32 seconds. And now we can just subtract. So 60 minus 32 gives us 28. 59 minus 11 gives us 48. And 89 minus 14 gives us 75. And that's how you subtract from 90 degrees. All right, now let's take a look at example 3. Convert 82 degrees, 47 minutes, and 51 seconds to decimal degrees. So this is really easy because you're just plugging it into the calculator. All right, so the 82 degrees can stay the way it is. But the 47 minutes, in order to convert that to degrees, you just divide by 60 because there are 60 minutes in 1 degree. And then the 51, remember we divide by 3,600 because there are 3,600 seconds in 1 degree. And now you can just, and that's a degree symbol, now you just plug it into the calculator and you get 82.7975 degrees. Okay, so converting from degrees, minutes, seconds to decimal degrees is pretty easy. But converting from decimal degrees into degrees, minutes, degrees, minutes, seconds is a little bit more challenging. All right, so we want to convert this to degrees, minutes, seconds. So we chop off the degrees, okay? And then we say, okay, well, now we have 0.614 degrees, and we're going to multiply that by 60, by 60 to get the number of minutes, okay? So when we do that on the calculator, when we do this piece on the calculator, we get 36.84 minutes. Okay, so then we got 36 minutes. We can chop off the 0.84 and multiply by another 60, because if this is 0.84 minutes and we want to convert that to seconds, we just multiply by 60. So we're going to multiply this piece, okay, we're going to leave this piece alone, and we're going to put that into the calculator. And we get 50.4 seconds. So 43.614 degrees is equal to 43 degrees, 36 minutes, and 50.4 seconds. Okay, standard position is going to be an important term in trig, okay? And that's when you have your angle's vertex at the origin, okay? We're looking at the coordinate plane, and so the vertex is at the origin, and the initial side is that x-axis, the positive side of the right axis, or the x-axis. The positive side of the x-axis, or the right side. Okay, so let's take a look at our quadrants. All right, so we've got quadrant 1, 2, 3, and 4. Hopefully we remember that. And remember, quadrant 1 is between 0 and 90. Quadrant 2 is between 90 and 180. Quadrant 3 is between 180 and 270. And quadrant 4 is between 270 and 360. Okay? So if we have an angle measure, say 54 degrees, that will be in quadrant 1. If we have 115, that will be in quadrant 2, and so on and so forth. Okay? So if we're looking at an angle in standard position, then say we have a ray coming off here. That angle would be measured from the initial side right here to that terminal side. So that would be somewhere in between 90 degrees and 180 degrees. If we had a ray coming off here, then that angle in standard position would be the measure from this initial side all the way over, okay? And then if you had one coming, we'll go black, off there, then it would be from the initial side all the way to that terminal side. So that's how you can measure an angle in standard position. Because remember, if you go clockwise, it's going to be a negative angle. Okay? So if you have a positive angle, it's going counterclockwise, with the initial side being this part of the x-axis. All right, so let's do that. Okay. Coterminal angles are angles that have the same initial side and the same terminal side, but they have different measures. For example, if you have, let's bring that back a little bit, if you have a ray coming off here, and we'll say this is, we'll say 45 degrees. Okay, so there's an angle. Its initial side is the x-axis. Its terminal side is at 45 degrees. Well, we could also measure that by looking at one full rotation. So if we start here on the initial side and we make a full rotation, and then we end up at the terminal side, that's a coterminal angle, but it has a different measure because you have one full circle added to that angle measure. So that angle would be 360 because of that full circle, plus the 45. So you would have, should be 405 degrees. So that angle measure is 405 degrees. Okay, so those are coterminal angles. All right, so find the angles of smallest possible positive. So we're looking at the smallest positive, measure coterminal with each angle. So 908. So the easiest way to get that is if it's above 360, just keep taking away a full circle until you get between 0 and 360. So 908 minus 360 gives us 548. Well, that's still not in between 0 and 360, so take away another 360. Full circle. These are all degrees. And you get 188. That is positive, and it's the smallest coterminal angle because if you take away another 360, you're going to get a negative answer. So 188 degrees is the answer for that one.